Imagine a single rock floating in space, just drifting there, minding its own business between Mars and Jupiter. Nothing special, right? Wrong. That rock, it's worth more than the entire global economy. We're talking quintillions of dollars. Yes, with a Q now. I know what you're thinking. That's ridiculous. How can a space rock be worth that much? Well, buckle up, because what I'm about to tell you is going to blow your mind, and it might just explain why billionaires are suddenly so obsessed with getting to space. While everyone's been arguing about whether we should go to Mars or back to the moon, a quieter revolution has been brewing. A gold rush. Except this time, we're not heading west in covered wagons. We're heading up. Way. And the prize. Enough platinum, gold, and rare metals to make every prospector in human history weep with envy. This is the story of asteroid mining, the industry that doesn't quite exist yet, but is already worth trillions. And by the end of this video, you will well understand why some people think this could either save humanity or trigger the next great conflict in human history. Let's dive in. The asteroid I mentioned is real. Its name is 16 Psyche, and it's one of the most fascinating objects in our solar system. Unlike most asteroids which are rocky or icy, scientists believe Psyche is the exposed iron-nickel core of a protoplanet, a baby planet that was smashed apart billions of years ago. It's essentially a giant, floating ball of metal. How much metal? Well, estimates put its value at around 10,000 quadrillion dollars. To put that in perspective, the entire world's economy in 2023 was about $105 trillion. So Psyche is worth about 100,000 times more than all the money on Earth combined. And Psyche is just one of many. There are millions of asteroids in our solar system, and thousands of them are classified as near-Earth objects, or many of these uneels are rich in precious metals like platinum, iridium, and gold, which are rare and expensive here on Earth, but are surprisingly common in space. These aren't just valuable for making jewelry. They are critical components in everything from your smartphone and computer to medical devices and catalytic converters. The supply on Earth is finite, and mining it is becoming increasingly difficult and environmentally damaging. So, the idea is simple. Why not mine the asteroids instead? Bringing back even a small asteroid's worth of platinum could crash the global market overnight. But the real prize might not be the precious metals at all. It could be something far more common. Water. Many asteroids are packed with water ice. And in space, water is everything. You can drink it, obviously. You can use it to grow food. And most importantly, you can split it into hydrogen and oxygen. Hydrogen and oxygen are the two main components of rocket fuel. This means asteroids could become refueling stations in space, a cosmic network of gas stations that would make deep space travel cheaper and more feasible than ever before. We could build and fuel missions to Mars, Jupiter, and beyond, all without ever having to launch heavy fuel tanks from Earth's deep gravity well. So, when will we see the first asteroid mines? Well, several companies, backed by some very familiar billionaire names, are already developing the technology. And NASA itself is on the case. Their Psyche mission launched in 2023 and is on its way right now to study that. 10-1000-Q UADRILLION $. Rock up close. But the challenges are immense. We need to develop autonomous robots that can land on a spinning rock, drill into it, and process its materials in the vacuum of space, all millions of miles from home. The legal questions are also a minefield. Who owns an asteroid? Can a private company just claim one? The Outer Space Treaty of 1967 says, no nation can claim sovereignty over a celestial body, but it's silent on private companies. It's a legal gray area that could lead to serious international disputes. A space gold rush could easily turn into a space war. Have you ever looked up at the night sky and wondered what's really out there? Beyond the stars and planets, there's a treasure chest of unimaginable wealth just waiting to be opened. And I'm not talking about some sci-fi fantasy. I'm talking about a real-life gold rush. A cosmic bonanza that could completely reshape our world and our future. This is the story of asteroid mining. So first things first. What exactly are we talking about here? There's this one particular asteroid. Its name is 16 Psyche. Catchy. Right. It's about 140 miles across, orbiting out there in the asteroid belt. And scientists believe it's actually the exposed core of a failed planet. Think about that for a second. A planet that never quite made it, stripped down to its metal heart. And what's it made of? Iron, nickel. And here's where it gets really interesting. Massive amounts of precious metals. Gold, platinum, palladium, the kind of stuff we use in everything from smartphones to medical equipment to catalytic converters in our cars. Now, estimates vary wildly, but some astronomers calculate the 16 Psyche alone could contain metals worth somewhere around $10 quintillion. Honestly, the numbers get so big they stop making sense. That's a 10 with 19 zeros after it. The entire global economy right now is about 110 trillion dollars. We are talking about 100,000 times that amount. From one single rock floating in space. But here's the thing. Psyche isn't alone. There are millions of asteroids out there, and a good chunk of them are absolutely loaded with valuable materials. In fact, there's this whole category called M-type asteroids, where the M stands for metallic. These are essentially flying mountains of metal, just hanging out in space, waiting for someone to come grab them. The asteroid belt between Mars and Jupiter. It's like a cosmic junkyard filled with the building blocks of planets. And unlike Earth, where all the heavy metals sank to the core billions of years ago during planetary formation, these asteroids never got big enough to melt and separate. So all the good stuff, it's right there on the surface, just ready to be collected. Okay, so space rocks are valuable. Cool story, but why does this actually matter for you and me? Well, let's talk about your phone for a second. That little device in your pocket. It contains about 30 different elements from the periodic table. Lithium for the battery, tantalum for the capacitors, indium for the touchscreen, rare earth elements for the speakers and the vibration motor. And many of these materials, they're getting harder and harder to find on Earth. We're running out. Not tomorrow, not next year, but the clock is ticking. Some estimates suggest we could face critical shortages of certain rare earth elements within the next 50 to 100 years. And these aren't just for luxury items we're talking about. These materials are essential for electric vehicles, wind turbines, solar panels, medical imaging equipment, advanced computer chips, basically everything we need for a sustainable high-tech future. And here's the kicker. Mining these materials on Earth is incredibly destructive. It requires tearing apart mountains, using toxic chemicals, and producing massive amounts of waste. There are entire regions of our planet that look like lunar landscapes because of mining operations, not to mention the human-caused polluted water supplies and destroyed ecosystems. But in space, there's no ecosystem to destroy. No indigenous communities to displace. No rivers to poison. It's just rock. Very, very valuable rock, floating in a vacuum. Plus, and this is huge, if we're serious about becoming a spacefaring civilization, we can't keep launching everything from Earth. Do you know how much it costs to get stuff into orbit? Even with SpaceX bringing prices down dramatically, we're still talking thousands of dollars per kilo. It's like shipping a package, except the postage costs more than a luxury car. But if you could mine materials in space and use them in space, you could build spacecraft, space stations, even habitats on the Moon or Mars, without having to haul everything up from Earth. Massive gravity, well, the economics suddenly start to make sense. So, who's actually trying to make this happen? Well, for a while, it seemed like everyone wanted a piece of the action. Back in the 2010s, two companies burst onto the scene with big promises and even bigger dreams. Planetary Resources was founded in 2009, backed by some serious heavy hitters. We're talking Google co-founder Larry Page and filmmaker James Cameron. Their pitch: they were going to prospect asteroids, identify the most valuable ones, and start mining them within a decade. Then came Deep Space Industries in 2013, with a similar vision. They even designed these cute little spacecraft called Fireflies that would scout out asteroids and bring back samples. The excitement was real. TED Talks were given, headlines were written. Investors threw money at the problem. For a brief moment, it felt like we were on the verge of a new gold rush. And then reality hit. Both companies failed. Planetary Resources was sold off for parts in 2018. Deep Space Industries was acquired by another space firm and basically dissolved. The dreams of asteroid mining seemed to evaporate. But here's what's interesting. They didn't fail because asteroid mining is impossible. They failed because they were too early. The technology wasn't mature enough. The costs were still too high. And perhaps most importantly, there was no clear path to profitability in the near term. But fast forward to today, and the landscape has changed dramatically. SpaceX has slashed launch costs. Private companies are successfully landing on asteroids and even bringing back samples to Earth. Japan's Hayabusa 2 mission collected material from an asteroid and returned it safely in 2020. NASA's OSIRIS-REx mission did the same thing just last year, grabbing samples from the asteroid belt. We're proving bit by bit that we can actually do this. And the players, they're different now. It's not just startups anymore. Established aerospace companies are getting involved. Governments are taking it seriously. China has announced ambitions for asteroid mining. Luxembourg, of all countries, has positioned itself as a legal hub for space resource rights. Even the United Nations has had to start considering the legal implications. So, where do we go from here? The path is still incredibly difficult. The challenges are enormous. We need to develop robotic miners that can operate in harsh space environments. We need to figure out how to process these materials in zero gravity. And we need to build a whole new space-based economy from scratch. But the motivation is stronger than ever. It's not just about getting rich. It's about securing the resources we need for a sustainable future on Earth. It's about building the infrastructure for humanity to expand into the solar system. It's about unlocking a future that right now still feels like science fiction. The first space gold rush might have fizzled out, but the second one is just getting started. And this time, it might just change everything. So next time you look up at the stars, remember that you're not just looking at points of light. You're looking at the future. You're looking at the next frontier. Okay, let's talk about the legal minefield of space. This might be even trickier than the engineering. Who actually owns an asteroid? Can you just fly up and start drilling? What if two companies want the same space rock? Welcome to the Wild West of space law. There's this thing called the Outer Space Treaty, signed way back in 1967. It says no country can claim sovereignty over celestial bodies. The moon, Mars, asteroids, they belong to all of humanity. It sounds great, right? Very utopian. Except, it doesn't really say if companies or individuals can extract and use resources. It just says countries can't plant a flag and claim the rock itself. So, in 2015, the US passed the Space Act, which lets American companies own whatever resources they pull from asteroids. Luxembourg and other countries have followed suit, but this is where it gets messy. International law is all about consensus, and not everyone agrees. Some nations argue that this violates the spirit of the original treaty. They want a more regulated, international approach, kind of like how we handle the deep seabed here on Earth. And honestly, they might have a point. If we're not careful, we could end up with the same colonial patterns we've seen throughout history, just relocated to space. The rich get richer, the powerful dominate, and resources that should benefit everyone end up in the hands of a few. There's also the question of planetary protection. Some asteroids might have organic compounds, maybe even precursors to life. Do we have the right to disturb them? What if we accidentally contaminate them with Earth microbes? These aren't just hypotheticals. We need answers before asteroid mining becomes a reality, because those answers will shape what kind of civilization we become as we expand into the cosmos. So, what's next? In the short term, the next decade is all about proving the concepts. We'll see more sample return missions, tests of mining tech in Earth's orbit or on the moon. NASA's Artemis program, which aims to get humans back to the moon, plans to test resource extraction right there. Think of it as a practice run, learning to get water from lunar ice before we try it on asteroids. Private companies are making moves too. Transastra is developing something called optical mining, using concentrated sunlight to get water from asteroids. Astroforge wants to refine platinum in space. These aren't household names yet, but they could be in 20 years. China plans to land on a near-Earth asteroid by 2030 and maybe start mining by 2050. The European Space Agency is studying missions. The momentum is building. Slowly, but it's building. And this is a big if the economics work, if the tech matures, if we solve the legal puzzles, the impact could be transformative. We aren't just talking about a new industry. We're talking about fundamentally changing our relationship with resources. On Earth, resources are scarce. We fight wars over them. There's a zero-sum mentality. Your gain is my loss. But the asteroid belt? It has more resources than humanity could use in thousands of years. Scarcity isn't the problem anymore. The problem becomes logistics, technology, and cooperation. It's a completely different paradigm, and it might just help us grow up a little as a species. Look, I'm not going to tell you asteroid mining will definitely happen or that it'll solve all our problems. The universe is always more complicated than we expect, but for the first time in history, we have the technology to seriously consider it. The rockets exist. The robots exist. The knowledge exists. What we're building now is the infrastructure and the economic incentives to make it happen. And whether it takes 20 years or 100, it's going to happen. Because we're explorers. We're builders. And when we look up and see trillions of dollars worth of resources just floating there, well, eventually, someone's going to figure out how to grab them. The gold rush is coming. It won't look like California in 1849 wheat pickaxes. It'll look like spacecraft, robots, and mission control rooms. But it's the same human impulse. The drive to explore, expand, and reach for something just beyond our grasp. Maybe 100 years from now, people will look back at this decade as the beginning of something extraordinary. The moment humanity stopped being a single planet species, Ormaibe, Te Ala Wonder Wo, took us so long. Either way, the asteroids will still be there, spinning in the darkness, carrying more wealth than kings could dream of. All we have to do is reach out and grab it. So, what do you think? Is asteroid mining the future of humanity, or just an expensive fantasy? Let me know in the comments below. And if you enjoyed this deep dive, hit that subscribe button. Because trust me, the story of our expansion into space is just getting started. Thanks for watching, and keep looking up.